Hey, it's W5HRO. I know it's been a while again this time. We just came back from a long trip. We drove all the way to Tulsa, Oklahoma, here from California, and we took the northern route that first weekend. We just came back this last Friday. It's Monday afternoon here in California again, and we just got back like a couple days ago, so 3 days ago. And long trip, almost 2 weeks. We actually started driving back from Tulsa on Thanksgiving Day, because we got there a week early. We decided we'd do the Thanksgiving thing like a week early, which is exactly what we did to beat the virus traffic and all the commotion and stuff. So it turned out pretty good. But while I was in Tulsa, I got some of my components that I needed for this RF deck before I left, and I found a 200K 50 watt resistor to add to the 200K 100 watts in parallel. So the power dissipation across these three resistors are going to be equal. So I got 100K in parallel with 100K in parallel with 200K, and that gives me about 40K. And it's going to do, like I said, these are 100 watt resistors, this is a 50, and these are 100Ks and this is 200K, so it's going to be, the power dissipation is going to be evenly distributed. And what I figured out is, when I had this thing working before, if you remember from one of my last videos, I discovered I had a short on this Pi network on the tank circuit on the output of the 4400 circuit, and there was no inductance. It was shorted across the whole thing because of that screw. And well, I couldn't get the thing to dip or do anything. But when it was doing that, I measured the screen voltage, and I was getting about right at 500 volts on the screen. I'd look underneath here, and I'd hit the PTT, these regulator tubes, these OD3s would light up, but then they'd go kind of dim, but they were still lit up just barely. So they were regulating at 500 volts, but the current was probably just right at 5 milliamps or just below. These things are not stable unless you have at least 5 milliamps running through them the whole time. And those are in parallel with the screen along with the clamp tube, so I needed a little bit more I needed less voltage drop to get more current to the circuit. That's what happened, because when I finally fixed that short on the inductor and I tuned everything and got everything drawn current, everything was loading properly, screen current, grid current, everything, and plate current and so forth, it dropped the screen voltage down to 459 volts. And when I hit the PTT, the regulators would blink, but they wouldn't light up all the way. So I mean, they would just blink and they would try to light and they just go completely dim. So it was the resistors were dropping the voltage, they were dropping the current too much. So I've got it now at 40K, and if you look at the meter here, if I go across from the input there, see, of the connector to the screen of the tube connection, the line, I've got 39.6K, so that's 40K. So that should be more than enough. That should give me at least 10 milliamps running through these things, because my main concern was I need to make sure there's still enough current to operate this clamp tube. So I wanted to make sure, if I really wanted just a little above 5 milliamps going through, but I figured it better be at least 10 or more. That way when I modulate, they should dim a little bit, and that'll work perfect. So I did that, and the other thing I found was, see this big resistor here? This surplus place in Tulsa had some 400K 7 watt 1% resistors. And what I noticed is, I've got this 5 meg screen pot in here, right? Actually, it came out, when I measured it, it's supposed to be a 5 meg pot, but it came out to 4 point something meg. It's like, matter of fact, I think it's a little less than 4.5. I think it was like 4.4 or something. So the tolerance was a little off on it, but that's okay. It was a new 2 watt pot. But with this so what I decided to do was, when I figured it out, was when I loaded down on 160 on the lowest frequency I'd ever be operating on, and when I loaded everything up, and I set the grid drive for the right amount of grid current, control grid current, the resistance, I measured the pot, and the resistance was right at 150K. So I've got almost a 5 meg pot, and I only need 150K to back it down on the low end for 160. So I thought, okay, let me swamp it out with like a 500K resistor, and then I couldn't find one. Then I found they had these 400Ks, or I thought that's close enough, right? So that should work. So when I adjust the screen voltage now on the 4400 tube to get the right amount of control grid current, it should be about right. Let me, what am I doing here? I got to go back here and try to see if I can't find the connections to this. I think that's one. And let's see, I think that's the other. Yeah, it's showing, see if I back the pot down all the way to get the maximum 5K, which is like around to get the maximum 5 meg, which is closer to 4.4 meg on its max setting. See, now it's showing 0.373 meg. Well, that's 373K. So that's swamping. And see, I go all the other way and it becomes a dead short. So that's full voltage on the screen. Now, so what I'm saying is this should be a smoother adjust. So swamping this pot out, and I did it on the back side here where the connector is, it makes it easier. That'll make the adjust a lot smoother. It doesn't really matter. I just need to make sure on the band where I've got the most, grid drive, that I can back it down to where it's going to be less than the 12 milli, or I can adjust it down, and so it's never, as long as I can always back everything down far enough, it's fine, and this will make the whole thing a lot smoother. So I've got that, and tomorrow I glued something down here. I want to let it dry a little bit, so I'm going to wait till in the morning, and tomorrow morning I'm going to come in out here and come down here and I'm going to slide it back in the rack, and I'm going to see exactly how much screen voltage I have on the 4400 now and to make sure that this swamping is going to work good. I don't think it's going to be a problem. This is going to make this adjust way smoother, so that'll be good. So I've got that, and the other thing is you can see here the loading resistors that I have, and let me stop, or I can't do it today because I put a little bit of glue down on a certain spot for a reason. I want to let it dry before I turn this thing over. If I turn it over, the glue's going to run. So let me let this thing dry overnight. I'll come out here again in the morning, show you one last thing, and then I'm going to slide it in the rack and I'll continue the video. But I'm just going to make this is going to be just part of the next video. I'm just going to stop it here now, and then I'll finish it up as we go here. So that's it for right now. Okay, I want to make one quick correction here. Sometimes when I'm talking about this stuff, I'll make what I call like a verbal typo. Maybe I should call them verbos. When I said loading resistors, I meant loading capacitors. And one thing I'm going to show you tomorrow when I turn this thing over after that glue dries is that I did take more plates off that big plate tuning cap. That was a big Chinese air variable plate tuning cap. It was for like broadcast transmitters. It was like 360 picofarads at max capacitance. And I was using that capacitor years ago because it worked all the way down to 160. I could tune on 75 and 80, and I could, when the corner of it was just barely meshed, I could make it dip on 40, but it would never work any higher than 40. So I took a bunch more of those plates off again, and I've got it to where when you got you got maximum capacitance, it's like 150, it's like 148, 149 picofarads. So I can dip it all the way down at 3.6 megacycles. And what I planned on doing was that if it was going to work like that on all the higher bands, if I could still dip it on the higher bands, I would just add I'll show you in the morning. I've got to wait till I can turn this thing over. I was going to add a relay in there to where I just parallel one big doorknob, the ground across it, to get it to work on 160 so I could dip it on 160. And I was going to remove the switch here that I was going to use for the AB bias from Class C to Class AB bias switching back and forth, because I have this little supply that I installed on here to make it work for Class AB. I was going to adjust it via these pots there. See, rheostats. But what I decided is, since I'm not going to use this thing on SSB, I'm not even going to attempt it. I'm going to redo this, and I'm going to make this to where I can use this switch back and forth to switch that capacitor, across this tuning cap to ground. Did I say loading cap or tuning cap? It's the big plate tuning cap. I just want to make sure I didn't make a mistake, because I'd have to go back and watch the video to see what I said. I might have done a verbo again. But anyway, I'm going to put a new switch in here. But the problem is, even now I've got it down to where this cap is set up for max capacitance. It'll work down on 80, right? The problem is the minimum capacitance is still like 32 picofarads, and I tried it and I cannot get the plate to dip on 20 or 17 meters, and that's the issue. I'm gonna have to, this is the problem, and I'll show you what I'm talking about tomorrow. But what I'm gonna wind up having to do is I'm gonna wind up having to put a multi-position switch on here to where I can switch a doorknob in, like in series with the plate tuning cap to get the capacitance way down for the higher band. And I was trying to figure out a way to make it work, and I don't think I can just make it work on 20 and 17 by reducing the capacitance. I think I'm going to have to reduce it twice. And I hope I don't have to do that. It means I'm going to have to come up with something fancy on that. But what I decided I could do on this other, since I'm not going to use this thing for AB bias anymore, it dawned on me I might be able, I'm going to draw it up when I have time. The main thing is I want to get everything else working first. I want to make sure I have enough screen voltage with enough current so the regulators stay lit. I want to make sure the clamp tube's working, and I want to make sure I can make it resonant on all the bands. That's the next things I got to finish here, right in a row. I got to double check those two things and then make it work on dip on the higher two bands and the lowest, like a 160. And I realized what I could do when I disconnect all this for the AB bias switching. I realized, you know what I can do? Because one of the things that worried me is these resistors, the power dissipation is just enough to you know, if I lose control grid drive, if I lose grid drive on the tube, and you know the clamp tube activates, it's going to drop all, I mean, this is going to be dissipating all the power from like 2100 volts down, and it's going to be like almost, it's like 40 some watts of dissipation. These resistors are just barely big enough, so you only, if it happens, you only want it to be on on that load for a short time. Otherwise they're going to overheat. Well, they'll probably be okay, but they're going to get way hotter than what I want. So what I thought I could do is, since I've already got this other supply in here in the relay, what I might be able to do is I might be able to make it to where when the grid drive goes away and the clamp tube activates and shorts it down the end down the ground, what I might be able to do is I might be able to make it to where when that happens, it's only on there for a couple seconds, and it switches, and the relay clicks, and it switches the grid to the fixed supply that's in here. That's what I'm going to try to do. I might be able to, there might be a way to where I can auto sense it to where if the grid drive stops and it goes to those resistors in the clamp tube, that automatically when that happens, it switches to it clicks the relay and it switches to the fixed supply. That might be good. That way it'll protect these resistors from ever getting too hot, because it'll just take the load off them instantly. So when it clamps, boom, and it just, you know, it switches the drive over. So that might be a good way to do this, since I've already got that supply in there. So whenever I do something like this and I go back and I decide it wasn't going to work like I originally had planned it to work, and I decide to do something different, I always try to use the stuff that I've already added for something else, and that's a good thing. So I'll just draw it up on the SPICE simulator when I have time, and I'll see if I can't figure that out. So anyway, like I said, tomorrow when that glue dries, I'm going to turn this thing over and I'll give you some more detailed information on that and what I want to do, that plate tuning cap. Then I'm going to slide it here in the rack and see what I get. So that's it for now. Okay, it's Tuesday morning now. I'm going to continue this video. I've been sitting here listening to the guys on the SDR receiver here in California. This is another SDR. There's some guys on 3877 right now. The guys get off 85, where they start fading out this time of morning. What time is it? It's 8:56 a.m. It's cold this morning. It's like 30-some degrees. I've got to get outside. I'm going to go out this weekend and start looking at that telescopic fiberglass mast I bought, and I'm going to figure out how tall I need to make it, because I'm getting ready to put that thing up. I got to do it before it starts getting freezing cold here. We had some rain here while we were on vacation, and we came back and the ground was damp, and it's softer now, but we need a little bit more rain. But I think it's probably good enough now. If it doesn't freeze, I can go out there and put it up. But back to this RF deck again. You can see what I did. I've got the plates, you know, reduced down to where on maximum capacitance it's like 148 to 149 picofarad. That's, you know, that's close enough to 150. And when I tuned it up, when I dipped the plate on 3.6 megacycles, it was like just like barely meshed. It was like about that. It was just barely tilted. So that's good. As long as it works down to 3.7 even, I'm fine. It doesn't even have to work down to 3.6 because I'm never going to use it down that far. But I was just trying to go to the bottom end of everything to see, just make sure I had enough C. And I can decrease this inductance some more, and it'll still have enough to get, you know, down below 3.7 megacycles. That the problem I have is that this is that old B&W 850 band switching pi network inductor with it also has 160. This was the big one. This wasn't just the one that worked 10 through 80. This is the one that worked 10 through down to 160. This was the bigger one. And this was the last one that B&W had in stock. I called them back in the late 80s, early 90s. I think it was like 89 or 1990. And the guy still had one of them left in stock in the bubble wrap. It's been there for years. The guy said, yeah, I'll sell it. You know, we still have it. It's, you know, we just, the last one we have, so I grabbed it. So I got the very last one of these that were ever produced that the Barker and Williamson still had on their shelf. This was the very last one of these. So I got it just in time before it was gone. And they also had the smaller one too that went down to 80, and I should have grabbed both of them, but I only grabbed this one because I could have saved the other one for a future project. And they had like 2 of those left, I think. But they only had this one of these that had 160 on it. But the problem I'm going to have is when I try to make this thing work on 20 and 17, I can't dip the plate. The minimum C on this capacitor, you know, if I do this, if I take all the capacitance off and just do that, the minimum C is like 30, like 31, 32 picofarads. Well, that's too much. So what I'm going to have to do is first of all, I think what I can do I've got to try to, first thing I'm going to do today is I'm going to try to get this this inductance down on this strapping. What I should have done was years ago, if you look at this, I mounted it this way because it was the most, you know, it was upright and it looked like it was going to be okay. At the time when I built this transmitter, I wasn't even thinking about anything above 40 meters. It was like from 160 up to 40, and it actually worked on 40, so I wasn't concerned about all the extra links and stuff. So otherwise I would have flipped this thing up the other way to where this one was up here close, and I could have put a short strap from there to there. So this is what I figured out is the way it is now, the minimum inductance on this thing is like 6 some odd microhenry, which is still, that's even too much for 10 meters. So what I did was, this used to have the 10 meter coil on it, the flat 10 meter, the real thick, that had like 2 or 3 turns, maybe 4 turns, and it was like going across from here to here. Well, I wanted to use that coil for 10 meters, so I took it off. I thought I'd use that for another amplifier, and I just put some strapping across here. And I did this in San Jose, and it was too long because I didn't have a vise there. I still don't have a vise, so the only way I could bend it, I'd put it around a piece, I think it was a 2x4. See the shape of it? That's what I did. But I actually made it a little bit too long. I should have made it a little bit, you know, shorter, for like, whereas like this part was here a little bit. But I just, you know, I was just trying to get a strap. I thought I'm going to use this thing no higher than 17 meters, so why worry about it? But I think what I'm going to have to do is I'm going to have to pull this extra strap off that I made and put that 10 meter coil back on to get the inductance down a little bit lower than the 6 microhenries. I don't mean, 6 microhenries. But this strap also adds to it, and then you got all this, you know, this threading here from the capacitor. There's so much extra metal on this cap that it's just going to be really hard. So what I'm going to have to do is, after I get this down, I think on 20, what I can do is, see, right, if you see the band switching thing there, or if I get the phone in the right place, there's 40 right there, and there's 20. And the 20, I can't get it to dip. So there's the 20 right there. See this? I think I can unsolder this. They probably use silver solder on this. I think if I'm using my big, I got one of those big 200 some odd watt Weller heat guns, the big one. I've got the high powered one that'll really get hot. So I'll take this off and I'll move it down to here or here. And then this other one for 15, I don't know what I can do. I may have to take that, I may have to put it like, take it off there and move it down here. Then I can use the shorter one. What I might wind up doing in the end to make this thing work properly is I may have to make it to where 18 meters is the last 2 positions. I use the 10 meter for the high end, and then the other one for the one before it for the bottom end, and then the other one for 20, which will be 20. But I think you know, it may not be as efficient. I don't care. Anything above 40 meters, as long as I get 200 watts, maybe, you know, between like 200 and 300, I don't care if I lose power, big deal. As long as I can dip it, get it resonant and make it work, that's fine. If the efficiency is down on the higher 2 bands, I don't care. But I don't think with the 32 picofarads max, when it's at minimum, you know, C position, I don't think I can get the inductance down low enough on this whole thing to make it, you know, where it's still going to dip. I think what I'm going to have to do is I'm going to have to cut this in half and put another doorknob, put like a 20 picofarad doorknob, or calculate out what it needs to be, and where I can have, what I'm going to do is, per my video, my part right before I was talking about this yesterday, is that when I come down here, and I'm going to remove the switch for that AB bias switch. I'm going to make it just, it's going to be just grid leak, and I'm going to try to make it to where the supply, this supply here, this negative supply, will switch through that relay if it loses grid drive. It'll go down through the clamp tube first. When it hits the clamp tube, it'll switch the relay and it'll use this instead. That's what I'm going to try to do. It may or may not work, but I'm going to see if I can come up with a circuit to make that happen. Because in the T368 exciters, when the clamp tube activated, you went across those big the dropping resistors for the load for the some odd thousand volts. It switched a thermal relay that clicked, and it disconnected it that way. But I might be able to make it where I can do the same similar thing to where it just switches to this supply. And I'm sure I can make that work. I'll come up with something to where I can make that actually happen. I don't think it's going to be too difficult to engineer that. It should be pretty straightforward. I know there's a way I can figure it out. So anyway, but that's the one thing. But so I'm going to use that switch, and I'm going to use it just to switch, relays. What I was going to do was, I was hoping that when I reduced the C down, this to 150 max, that what I could have done was just, I would have needed one for 160, right? I would need more C for 160, because what I originally had, this big cap. What this was, it had plates all the way from here all the way to here. It was 360 picofarads at max mesh value, and it worked great. I could dip the plate on 160, and when I was on 40, I mean, I'm not kidding you, the plates were like just barely meshed like that, but it still worked on 40. It was just never going to work on any other higher bands. So I thought, well, let me reduce it down, remove a bunch of plates. I did it once, it didn't get it down enough, so I removed the ones from the other side. See, I centered it up. I probably should have made it so the plates were all the way down here. So this is going to add inductance here, this metal threading, I think. But at the same time, I still would have had all the metal on the other side. It probably just would have added more. It's going to be more metal. It would have added more inductance anyway. So I don't think it would have made a difference. But if I leave this on here and I go from here to the other point and I check the inductance at minimum minimum L, it's like 6 some odd microhenries. So it's, no matter what I do, it's still too much. Because for 10 meters, it's supposed to be like about 2 to 3 max, I think. So, that's what I was going to, but what I was going to do is I was going to make it switch the way, if it worked on the higher bands, I would just, for 160, I was going to add a relay to make it to where there's a doorknob just mounted right here with it connected to here, to where the relay, when I clicked that switch on the front, just a 2-position switch, it would turn the relay on, click, and it would add more parallel C across this tuning cap to ground, and then I could get the extra C I needed for 160. I thought, well, that will be simple, but it looks like now I'm going to have to do like a multi-position thing and, figure out a way to do it. I'm going to have to probably put one in series here to get it down to tuning on 18 and 20. It may take 2, and that's what I'm worried about. I'm not sure I can make it work. That's why I was thinking I might have to make it to where the last position that was originally for 10 meters is the top end of 17 meters. And then the position before that is the bottom end of 17 or the top end of 20. I'll have to figure it out. I'm going to have to figure out some combination to where I can dip the plate on those 2 higher bands from the high end of that band to the low end. So that's what I got to figure out next, and I still have to add the one that parallels for 160. So that's going to be at least 2 positions, if not 3. And it's going to require, that's the thing, it's going to require more than one relay, and I really don't want to do that. So I'm trying to figure out how I'm going to simplify this. I mean, I could always remove a whole bunch more plates off of this thing to see if I could get the minimum C down as far as I could get it. And then if I could get it down like to 20 or maybe a little less, there's so much metal, I don't think it's going to get down that far. I might be able to get it like 20 some picofarads, but I think that would be it. Then I could just, even for 75, I could just parallel the caps to ground across. Just one relay adds one doorknob to ground, and you click the switch again and adds one more doorknob to ground, for the next lower band. That might be simpler, but I really don't want to take this out of here again. I mean, right now this thing tunes up on 75 and 40 just fine. I just got to make it work on 160, and well, the first thing is get to work on 20 and 17, and adding the parallel cap to ground the last. That's the easy part. It's just, how am I going to do this? Am I going to have to put the series cap in here after I get this down, get the inductance reduced to where, you know, I can get it down to where, because the minimum, see, 30 some, like it looked like it was about 32 picofards at minimum value, so that's too high. And there's not a whole lot I can do about it except try to adjust the coil to reduce the inductance to compensate, and then add like some, you know, series capacitance in here to fix it the rest of it. So that may be what I have to do. But that's what I'm going to look at today. I'm going to dig out the 10-meter coil I took off of here, and I'm going to put it back and see what that does. And it should reduce it down some, but I'm still, if I could just at least get it to work on 20 without having to add series capacitance here, then I could just add one series capacitor in line for 17, and then one parallel for, that would be fine. Then I would just need a 2-position switch. And the power supply is already in there, and everything's in there. The relay's there. It's just, I'm just going to have to it's going to be a simple fix. I mean, I don't need to change the relay or anything, but what I'm saying is the switch is there. Basically, the line that's going to that switch is already there. That 1-position switch back or 2-position back and forth for the bias switch. I'm just going to use the switch, but I can just take that line that's going to it and move it around for a sense circuit to do the other thing I was telling you about. So that's what I'm going to do today. But right now, what I did was I just want to put it back in the rack here next, and I want to see if you know what it's going to do. I want to make sure I got the screen voltage up all the way, the full 500 volts, because I've decreased the dropping resistance of the screen dropping resistor circuit to like from 50K down to 40K, and I'm going to and I did the other. So I want to see what those two things that I did yesterday, like I put the swamping resistor across this jack in the back to swamp out that 5 meg pot for the screen adjustment for the tube to control the amount of grid drive. So let me get the thing put back in the rack, because that's going to be the next step here. And then after I get that done, I'm going to upload the video when I get this next step done here. When I put it back in the rack, I'll take a video of that, and I'll combine all these videos and make it one video, and I'll post it. And then I'm going to pull the thing out, and then I'm going to work on trying to get these higher bands and the lower band to work. So that's it for right now. Let me slide this thing back in the rack. Hey, here's the last part of the video. I got 400 watts out of it now on 75. I can probably get it up a little more, but if I hit the PTT, I'm seeing 400 watts. Now I need to change the loading, because I got just about 300 mils of plate current now. It's supposed to be 330, so it's the loading. When I try to load it, I can tell what's going on. I can't get it up any higher. I remember when I took the loading caps out of this thing originally, I had two of those loading caps screwed up, one on top of the other one, to get the capacitance down by half. And it's one of these, I forget which position it was, but that's why, because I can't get the loading. Even when I max this guy out or minimize it, the loading's in the wrong position. So I've got to tweak the loading caps in there. I think I have to add that one in series with it again to get the right combination that I need for all the bands. But I'm getting, see how the meter's it's below 0, so it's showing it, a little over 30 mils, but that's because, well, once I get the full amount of the plate current, when I get up to the full 330, it'll actually back down there. But I've got to tweak the loading, because it's obviously not in the right place. I don't have the exact, because no matter what position I use, I can't get it up high enough, so I've got to change it. But I do have the full screen voltage now. I checked it, and it's 500 volts. Look what they do now. Look at the regulators. So when I transmit, they're going to flash, and then they're going to stay lit. See? They stay lit. So I got 500 volts of regulation, and I could put a current meter in there, but I'm guessing it's somewhere around 10 milliamps of current. Could be a little less, could be a little more, but that's about right. So that's good. And as far as the loading, let me turn the plate switch off down here so I don't have the high V, so I can just do the driver by itself, or the exciter. See, it's nice. See, when I turn this knob all the way down with that, see with that what do you call it? I drew a blank. What I call that resistor I put in there, swamping resistor in there. See, I can't get it down lower than that, so that's perfect. So I just need to make sure on the other bands, if it won't get it down enough on 40, I'm going to check that next. I'll have to decrease that. I mean, I'll have to increase that swamping resistor, but I think it's going to be okay. That's good, because it, you know, that's, yeah, see, I can get it down just below 10 mils. So see, that's going to make it a lot smoother. And it's also, it's not going to let it get up as high, and it's going to protect. I can already tell it's like way smoother than what it was. So that's an improvement. So that's going to help, and it also protect that 2-watt pot with that 400K swamping in there. So it looks like I've got this thing to work. I'm going to check it on 40 next, but I think it's going to be okay. Let me stop the video real quick and just double check it again on 40. Okay, I have it on 40, and when I back this screen control pot all the way down to get the grid drive down, it drops it just down below 10 milliamps like the other one. So that swamping resistor is working fine. However, when I dip it, the loading I'm going to have to change. I think I'm going to have to add a couple series cap in there with I'll have to screw 2 doorknobs in series with the other ones to get the capacitance down. What it is even the first couple positions off, if you get off this one, that's just using this cap by itself, but you get on this one, I need the first one for 40. This other one's going to be for the highest 2 bands, but this one's going to be for 40, and that loading cap is too high. It's still too high. And this one's too high for 7580. So I've got to decrease the capacitance there and decrease it there to get it right, to get the current up on the plate. Because what's happening is, let me show you. See, that's as much plate current as I can get. It's just, what is it? It's about just under 300 still, but it's still too low. It's like 282, 260. It's too low, and see, the screen current's a little too high. It's because I need to get the plate current up. It's the loading C, so that's what I got to do next. Looks like everything's working now. I just got to get the loading C down. And let me double check the regulators in here again, because they're probably drawing more current. Once I get the plate current up, the amount of current the screen draws is going to decrease. See, they still stay lit, but they're dimmer than they were on 80. So that tells me I just got to get the plate current up. So it looks like that 40K of dropping resistance in there is the trick. So that should take care of it. So that's looks like I've made a lot of progress. I'm getting power out. I've got the power up now to 400 watts on 75 meters. I just need to adjust the loading to get it up, because it should do just under, it should do over 4. It should be somewhere between 400 and 500 watts out on carrier output. So this thing should be gooder than snuff pretty soon. I just need to tweak the loading next, see what that does, and then I'm going to work on that inductance to try to get it to work on 20 and 17 meters. So that's it for now. This is W5HR, and back to the grindstone on this.